Good morning, everyone. Happy to talk to you all virtually. Today, I'm here to present about the topic biomedical relation extraction with state-of-the-art neural models, which is currently one of the research works under progress. Biomedical text mining involves the exploration of data embedded within the biomedical literature. In today's world, with the availability of scientific biomedical databases such as PubMed and PubMed Central and various other annotated datasets, the possibility of explorations in this domain has increased, which has led to more research focus in this area. Biomedical text mining involves various tasks such as named entity recognition, relation extraction, question answering, event extractions, and so on. In this discussion, we will be focusing on relation extraction, which is one of the challenging tasks in biomedical text mining. In general, the problem statement for relation extraction can be defined as follows. As input, we have a biomedical abstract or biomedical text and the entities involved in the abstract. And our goal is to extract the relations that exist between the entity pairs. The general workflow of such a system is depicted here, roughly. So first, once we have the biomedical text or biomedical abstract as the input, the initial goal is to identify the biomedical entities which are involved in this text. So there will be different entities like a protein, a gene, disease entity, and so on. So this will be done by an entity recognition algorithm. And once the entities are identified, our goal will be focused in extracting whether there is a relationship between the entity pairs with respect to the given biomedical text. So this can be modeled as a classification task, which can be either a multi-class classification or a binary classification task. In general, any relation extraction problem can be defined in different complexity ranges based on some of these parameters, such as the number of entities, where the complexity can vary from entity pairs to multi-entity relations, the span of the entities from intra to intersentential relations, wherein the entities can occur within a single sentence, or it can span to multiple sentences. Then the number of classes, which can vary from binary to multi-class relations. In the existing literature, there were different representation schemes and models used for biomedical relation extraction. It varied from the classical back of words and TF-IDF approaches to the embedding-based approaches and latest transformer-based models. In the current study, we had explored the deep learning models, the neural models, and we have explored the models such as bidirectional LSTMs, BERT models, and combination of BERT representation schemes with LSTM and the attention models. For the present discussion, we will be focusing on BERT model because it has achieved the state-of-the-art results on various NLP tasks, including relation extraction. Specifically, we had used BioBERT, which is the bidirectional encoder representation for biomedical text mining. And we had used two main data sets, chemical protein interactions dataset and chemical induced disease dataset for our studies. The motivation behind choosing these two datasets was that it involves the two main complexity ranges that we had discussed earlier. So in ChemProt, it involves multi-class classification, while in CDR, it involves both intra and intersentential spans of entity relations. For the current study, we had not focused on multi-entity relations. So we will be going briefly through the study done with the BERT model. So as discussed, the task was modeled as a classification problem. And as we use BERT for sequence classification, in which we can model it as a single sentence classification or sentence pair classification task. For the final model, we use sentence pair classification task, where we use the sentences in which the entity pair exists and the entity pair as such that constituted the sentence pair. And for preliminary experiments, we use BERT model, which is a transformer model with 12 layers, and this was fine-tuned with the discussed datasets, that is CDR and ChemPro datasets. And we achieved approximately 70% of F score for ChemPro and about 65% of F score for CDR dataset. In this discussion, we will not be focusing much on these figures because BioBERT has already achieved very good performance in this relation extraction domain. So we will be focusing on some other factors which could help in improving the model performance. Of course, one of the main factors is hyperparameter tuning. Another factor, as I discussed, was the representation of the task. So we experimented with single sentence and sentence pair classifications with respect to BERT model. And we found that for relation extraction, sentence pair classifications were giving better performance compared to single sentence classification. Next important factor could be the data set for training. So in this task, the training data is not available as such. We have to construct the samples from the given text and with respect to the given entity pair. So there are different approaches which could be followed. So we could have an abstract level sample selection. That means we consider the entire abstract as the sample. Or we can go for sentence level approaches where we could select all those sentences in which the entity pair exists. And then finally, for deciding the final relationship between the entity pair, we can go for a majority voting scheme. Then there are different approaches to select the samples, which is currently our focus, which is somehow related to distance supervision methods where we reduce or remove the noisy samples. So in this way, we will be selecting, our aim is to select those sentences which could provide some meaningful relationship and which in turn help in better learning for the models and thus improve the performance. And here we are focusing on using different NLP approaches like parsing, then dependency-based features, etc., and attempting whether they could help in such sample selections. Then another important challenge is to select both intra and inter-level sample selection, where intra-level sample selection is easier, but inter-level sample selections is much challenging because selecting samples, that is different sentences in which the entity pair exists and which could convey the meaning is difficult. Now, another focus of our research is to interpret the models, which is one of the hotspot research topic, that is to define the explainability of the neural models. As a starting point, we used attention visualizations, which helps us to get the attention focuses at token level or sentence level, which in somehow helps us to define the predictions of the model and get some intuition about the interpretability and do some error analysis. With respect to the BERT model, we use BERTVIZ, which is an open source tool which helps us to analyze the attention layers for the BERT transformer model. Here, an example from the ChemPro dataset for antagonistic relation is given. So we are visualizing the last layer, head 10. So the focus is on the CLS token. because the final prediction is obtained by pulling the CLS layer, CLS tokens, and we could see that the focus is on the token antagonist, which provides some intuition about the prediction because this was a true positive example. But attention itself may not be sufficient for interpreting such models, so we are digging into more details and looking into the literature to find more recent approaches for interpreting the neural models. So in this discussion, we have seen our preliminary experiments and approaches or study to analyze the neural models for biomedical relation extraction, specifically the BERT model and other factors which could impact the performance of the model, and analyze the interpretability of the models using attention visualizations. In future, as discussed, we want to analyze more methods for effective sample selections, and integration of knowledge bases is another direction. Then we want to dig more into the explainability of the neural models. Thanks for your attention.